Hello guys, welcome to Let's Code. In this video, we are going to discuss the cheat sheet for Spring Boot interviews for senior Java developer. So let's start with core concepts. Then we will cover security, microservice, performance monitoring, testing, and common pitfalls. So let's get started with topic core concepts and what are the subtopic under it. So in core concepts, first topic we have why Spring Boot, what is the difference between Spring and Spring Boot, what is starter dependency, Spring Boot starter web, Spring Boot starter data JPA, what is starter customization. The next topic we have profiles. What are the different profiles? Dev, UAT, QA, local, and prod. The next question interviewer might ask, what is layered architecture? How you have used actuator to monitor application and do the health checks of Spring Boot application. The next topic we have IUC container and dependency injection. What is inversion of control? What are the different ways for dependency injection? Then we have AOP, aspect oriented programming. What is aspect oriented programming? How you have used aspect oriented programming? Why Spring Boot uses aspect oriented programming? What is cross-cutting concerns, what is aspect, what is join point and advice, and what are the core concepts of AOP. The next topic we have uh, embedded server like Tomcat, JT, Netty, Undertow. Which server you have used in your application, whether Tomcat, the default server, or any other server. Which server is blocking in nature and which server is non-blocking in nature. The next topic is dev tools. What are the dev tools and have you used dev tools like hot reload and auto restart? The next topic we have Spring Boot CLI. What is the purpose of CLI and how it helps? What are the steps to create and what are the advantages and some common command? Then we have lazy and eager initialization. Then we have to use lazy initialization when we have to use eager initialization. What is the advantage and what are the drawbacks? So the next topic we have application event. Why we use application event? What are the benefits and how to create application event? The next topic we have error handling. When any exception came in our Spring Boot application, how we are going to handle that? What is controller advice and what is handler method? What is error controller? Then we have externalized config. What is externalized config? Why we use external config? What is the config server vault and Kubernetes secret and Azure key vault? So now we have covered core concepts of Spring. Let's look into the Spring security. So interviewer might ask what are the key feature of Spring security. Then we have authentication, authorization, and what is the difference between authentication and authorization. What is filter chain in Spring security, how to implement username and password based authentication, LDAP or in memory. Then we have token based authentication, JWT stateless or opaque stateful. Then we have OAuth 2 implementation, YDC with Keycloak, Okta, Azure ID or Cognito. Then we have multi-factor authentication. Then we have social login, how to implement social login with Google or GitHub. In authorization, we can implement access control. Access control might be role based, RBAC, or permission or scope based, PBAC. Then we have attribute based access control, where we allow login from any specific IP or organizational unit. Then we have policy based authentication like OPA and Keycloak. Then we have API gateway, edge security, where we implement centralized authentication, where gateway verifies JWT or OPAC token before routing. Then we have rate limiter, throttling, and web application firewall in Spring API gateway. We can also implement token relay. Then we have service to service security, like mutual TLS certification or token propagation, where we pass JWT or auth2 token between microservice. Let's look at some of the best practice that we need to keep in mind while creating any Spring Boot application. We have to create short-lived access token with refresh token. We have to follow the principle of least privilege, where we give least privilege to any user. Then we rotate keys and secrets. Then we have actuator endpoints, where we prevent unauthorized access to sensitive application information and management operations. We can also disable the CSRF token in stateless APIs, where we are using JWT token based stateless authentication. We also have to implement a strong password policy with hashing algorithms like bcrypt or argon2. Then advanced security topic comes like CQRS policy, reactive security, how to implement non-blocking security chain, auditing and accountability with the help of created by and last modified by annotations. Then we also have a topic threat protection like CSR or XSS click checking. We also have to implement zero trust, never trust inside network, where every request have to be authenticated. Without authentication, we don't accept any request. Then we have API scopes and claims. We also have session fixation protection, security testing like penetration testing, dependencies we scan with help of OWASP sync or SonarQube. Now we have covered basic concepts and security. Let's look at topic from microservice. In microservice, we have configuration management. What is Spring Cloud config called console, and Kubernetes config map secrets. What is feature toggles and Spring Cloud feature flags. Then we have service discovery. Questions like what is service discovery and why it is crucial in a microservice environment. Explain how tools like Eureka Console or Zookeeper work, how Eureka server and client communicate with each other in Java microservices, how to register Java microservices using Netflix Eureka. Then we have Kubernetes DNS, HTO, sidecar pattern for polyglot services. Then we have resilience and fault tolerance, circuit breaker. What is circuit breaker pattern in Java microservice and characteristics of circuit breaker like retry fallback or bulkhead isolation, how to do rate limiting, bucket 4J or with gateway. What are the different strategies of rate limiting like leaky bucket. Then we have distributed transaction like sagas, orchestration or choreography. Questions like how you have handled distributed transaction in a microservice architecture, what is outbox pattern and idempotency keys, how to avoid duplicate idempotency keys, how to achieve eventual consistency. Then we have communication styles. Questions like how do microservices communicate with each other, how we can implement asynchronous communication between microservices with help of Kafka, RabbitMQ, what is event-driven architecture and CQRS, what is event sourcing. Then we have observability, where questions like metrics tracing and what is centralized logging might come. Then we have observability, where Micrometer, Prometheus, what is metrics tracing and how to implement centralized logging. Then we have API design, REST, JSON or Hatheos. Then we have gRPC, binary or Hyper, GraphQL, how to implement GraphQL, flexible client-driven queries, how to implement OpenAPI or Swagger documentation with APIs. The next topic is data management. How do you ensure data consistency between all microservices? What is database per service design? What is polyglot persistence in PostgreMongo or Neo4j? What is data replication strategies like event sourcing or CDC? Then we have deployment, how microservices are deployed in Kubernetes or Docker. What is sidecar pattern, service mesh, Envoy or Istio? What is canary deployment? What is blue-green deployment? And what is rolling updates? Then we have security at microservice level. What is token propagation and mutual TLS between services? What is API gateway auth enforcement, where we implement centralized auth in API gateway? What is secret management? Then we have best practices for microservices like 12 factor app principles, backward compatibility for APIs, versioning APIs, graceful degradation and timeouts, and avoid God services, maintain timed context. So the next very important topic is how do you do performance monitoring, whether you have used Prometheus, Micrometer, metrics and monitoring. How would you implement a robust custom health check in production environment? What is Micrometer, Prometheus? And how you have used JVM matrix to monitor threads and CPU loads, and how you have monitored business metrics or success ratio. Then we have custom metrics using meter registry. The next topic is tracing. We have distributed tracing. What are the main challenges with distributed tracing in Spring Boot microservice, and how you have implemented distributed tracing using Slack or micrometer tracing. Then we have backend tracing using Zipkin Splunk. Then we have traced context propagation across asynchronous calls. Make sure you have trace ID in asynchronous call also, otherwise you will lose the tracing. Then you have correlation ID, trace ID, and span ID into MDC. The next topic is logging, how you have configure and manage the Spring Boot logging in production. You have structured JSON logs or correlation ID for request flow tracking. Then you have also masked the sensitive data. Do not log any PII data, token, passwords in logs. You have to mask that data. Then you also have to implement centralized logging using Fluent or Logstash sidecars. The next topic is startup optimization. How do you have optimizes the startup time of a Spring Boot application in a production environment? In startup optimization, we have lazy initialization to delay bean initialization until needed. Then we also limit the component scan scope to restrict the scope of component scanning using component scan to include only essential package. Avoid creating any unnecessary beans during startup, especially for time intensive services. Remove unused starter dependency. Also analyze startup with Spring Boot startup actuator. Then we have runtime performance optimization. We can also switch to web client from REST template, or in performance optimization questions like caching in Spring Boot application, connection pooling, tune max pool size, Hikari CP connection pool. Then we have async processing with help of @async annotation for Kafka and Rabbit MQQs. Then we have batch inserts and updates. The next topic is database performance. How you have handled transaction in a Spring Boot application. Have you used indexes, pagination views, or projection? How you have avoided n+1 queries problem, and how to use read replica caching for scaling. Then we have API performance using gzip and JSON compression, which is caching headers, pagination and streaming for large responses. Then also we have a rate limiting to avoid downstream overload. Then topics like resilience and self-healing, where circuit breaker retry, actuator health checks, Kubernetes props, or restart unhealthy pods, then graceful shutdown. There are some best practices for performance and monitoring, like monitor SLO, latency, throughput, error percentage, SLS and SLI, then canary deployment, green deployment. Then we have profile memory, threads, JFR, and sync profiler. Then load testing, we have JMeter Gatling. Then we have guardrails, timeout everywhere. If you don't have a timeout, then a thread will be retries infinite times, and that thread will be blocked. So now the next very important topic is testing, where we have unit test with JUnit 5 and Mockito library. We have to mainly focus on business logic, not on Spring context. We can also mock dependencies using mock or inject mock. We can also write parameterized test using parameterized test notation. Then we have integration test, slides test, then we have infrastructure test. In many applications, we also have contract testing, end-to-end testing, performance and load testing with the JMeter, where we measure throughput and error percentage, capture the latency. Then we have chaos and resilience testing. Then we also have some testing best practices to keep in mind, like follow the given when then pattern, arrange act assert style. So now we have covered all the major important topics. So now we are going to see what are the common pitfalls, like dependency management, overbroad using of component scan, that might lead to slow startup or creating unnecessary beans, bad jars with unused dependency that provide a larger attack surface and makes our application vulnerable. Then we have class path conflicts, like when Jackson and SLF4J is used, then we deploy runtime error, not locking the dependency version, that will break over time. Then we have configuration issues, like hard code secrets in application instead of using vault. Then we have wrong properly precedence, where we override the environment variable. Then we have mixing of profiles in dev UAT. Then we have security risk, like exposing actuator endpoint publicly, or using default password in DB or message broker, not using HTTPS or MTLS between services, or logging sensitive data like token, password, or API. Then we have reactive or blocking mistakes like calling blocking APIs inside webflux that might lead to thread starvation, or mixing monoflux with blocking code like using thread.sleep or .block method. Then we have database pitfalls like n plus 1 carry problem in Java, JPA and Hibernate. Large results set loaded into memory, not implementation of pagination or streaming. No connection pool tuning with Hikari connection pool defaults too low for prod. Running schema changes manually instead of live or liquid base where we migrate the schema. Then we have performance and scalability where not tuning JVM in Docker or Kubernetes, like wrong heap memory size. Then ignoring GC tuning for high throughput services, not implementation of caching. There is no request timeouts, then thread blocked indefinitely. Then we have some microservices pitfalls like tight coupling between services. There are no API versioning, and we have overused synchronous REST calls and ignoring even as well consistency. Then we have testing anti-patterns like using Spring Boot test that slow the test, and unnecessary context loading is there. We do not have to mock everything. If we mock everything, then our test cases don't catch the real bugs. Then we have some deployment pitfalls like building fat Docker images that slow our CI/CD and security and expose our application more to security vulnerabilities. Running apps as root inside container, no readiness liveness props in Kubernetes, traffic sent to dead pods. That are the cheat sheet for Spring Boot application. Okay, so now we have covered the major topics of Spring Boot interview questions cheat sheet, where we have covered core concepts and then security. Then we have covered what is microservices. After microservices, there is testing, performance monitoring, and we have seen the common pitfalls. So these are the bare minimum topics that you should know before applying to any Java Spring Boot developer position. Thank you.